Our first presentation is by paper ICACC3 by the title A Novel Self-Maintained Solar Panel Design and Development. The authors of the presentation are V. Rajagiri, A. Venkata Sivaprasad, and Gurgaon.
So this is a more different design of the self-maintained solar panel. So actually, the starting stage from the starting stage from the boy is traveling with his father in the car, and he just sees the solar panels over there. From there, he just understands something, and that is the work he has done according to his work. So normal design and development of the self-maintained solar panel. Okay. So this is a presentation. First part, the question is arranged from the fields of the state of Manna Pradesh. So that is the question of research and abstract and introduction. And the impact of the research question is regarding the best impact on the efficiency of solar panels and how we arrive at the best and how the experimental conducting on those problems. So in recent times, the word is repeating for the several number of times solar. As you all know, why we are using the solar energy because of this various advantages regarding the other renewable energy sources. So I don't want to mention put a lot of time regarding that. And simply it is comparing to the all renewable sources, it's giving the better outputs. Apart of that one, it is the high maintenance cost that we have reduced in this proposal system. See, this is the question of research. And you have seen the statistics from this is from the 2009 and the utilization of the power from the overall the global, and it is the consumption for the 1 year of the solar potential and 100 years of this energy consumption, old energy consumption. So we can, by using the solar energy, we can desperately fulfill our energy needs. That is the major agenda. So that is the question of research. Why? Because we selected the solar instead of any other resources. So this abstract is simple instead of the notes is in the past. Just understand the theme of the talk. As it's in the recent times, the development of the on the renewable energy sources by the ministries, as it is close to this, and because for them to fulfill the needs of the energies. But you all know in the recent times we got the coal crisis. So that will be simply done by using of this renewable energy sources. Okay, and the figures is shown. It is the for the 2020, the Ministry of the Renewable Energy Sources are interested to put the 13 crores nearly related to that. Okay, and this is the so we already done. The solar panels are installed, and we are getting the powers and everything is from the solar. But the main area is the dust impact on the solar panels. So these are the major regarding to the dust impacts. As you see, little bit means even though these are very small, but these impacting the efficiency of the solar panels. Okay, so these are the some of the reasons we the impact of the solar, right? Like the water sufficiency, the transportation. As we all know, so it's mostly in the need of the needs. So the dust particles will be settled on the solar panels, and it's creating the disturbance in the efficiency which is getting from the solar panel. So this is the best example and visual representation. This happen is you will clean the solar panels, which is a cost is very high to maintain that one. And it's also a little bit of risky to maintain the things. And this is the dust impacted on the solar. And this is some of the birds and other things in the paddy fields. So you see the proposed in the recent studies I have seen the performance reduction due to the dust elements. In the various not only in India, in the other countries also. In our country, in my state, it is from 3% to 7.6%. In the span of 45 days, the efficiency in the same in the United States of in 4.7, in Saudi Arabia, in some other countries along with us. So simply, what I am telling you that is efficiency is the most important in the solar panels. But here, due to the dust accumulation of the solar panel, the efficiency is getting reduced, and we are getting the less outputs, and the cost of the building is high. All those summating will be someone on the somebody so this is the variable, and the previously existing systems as the self-controlled systems means there is only controlling. In the proposed system, it will be cleaned by itself. The solar panels will be cleaned by itself. Okay, so this is the existing system. What they are done is this: they are using simply the current and voltage sensors. Then it will use to the nearby areas, and it will be report what is the current and voltage recorded in nearby areas. If the voltage and the current levels are reduced to the matching levels, then mechanically those people go there. As you see here. So mechanically those people could go there and clean the panels. So instead of that one, we have done the system, proposed system is a self-cleaning. Means, so yeah. So this is the main evolution. Have you seen the DC motor here? And this is the panel arrangements. The rollers will be moved. This is the brushes, and these are the wipers. And the this motor will rotate this roller from this side to other side. And the brushes and the wipers will be moved from this right side to the left side, and again from the left to the right. So in this way, the panels will be getting cleaned and the efficiency will be increased. It is a simple existence. Right now, existing systems will came from the self-cleaning systems, but this is for the already existing system, and we already implemented these systems in our for our solar panels in our paddy fields. So these are the some theoretical aspects regarding to that one. Means how the current and voltages will be impact on the panels, and how the each cell will getting the power. So that is the regarding in the point. And these are the experimental conductors for the particular days from the 21st February, from the with respect to the different radiations, and we get the voltage and the current from the panels. So this is the indoor for the proposed system, and we done the same for the outdoor conductors. Why? Because we done with the indoor and outdoor means to just understand what is the performance difference between both the things. And this is the next outdoor system, and we have done the same radiations at the same time. And this is the power differences for both the things. Means for the at the same day from the morning to the evening, we just conducted the experiment for the different radiations, and this is the power differences. So this is the final power difference for the indoor and outdoor systems. And this is a prototype what we have designed for the small panels, and with the same implemented the outside. As you've seen, the basic orbital chip, and this is the driver motor, and this is the DC motor. So you have seen the panels here, the same slated here. The roller holders are there. We just cover the sheet over here. The rotor will rotate, the motor will rotate this roller, and the cover is over this, and the wipers also rotate to this one. So when we switch on this motor, it will be rotated from this side to this side. So the wipers attached to the screen will be clear the dust, and it will be protected from the external dust also. So that is the basic prototype we have designed. Okay. And so this is the hardware implementation for the small, and this is the voltage and the currents what we are getting for the maximum power compared to the existing systems. So this is the differences between the current clean PV energy and the PV energy. So we get these capital differences for both the things. Means with the what the proposed previously existing systems exist, and right now the proposed systems. And finally, we have studied regarding to 21 days. Means with the existing systems, we have the power loss of the 13.46, and the efficiency increased to 18 to 22% per our proposed system. Okay. So that is regarding to the self-maintained solar panels as a basic one. So this is the basic thing we have designed by our own, and the diagrams also implemented by our team without copying from the internet. All these are self-designed, and this is the final output what we have came across, and this is the final results what we have got from the work. This is any doubts?
So that this system is better than the conventional. How did you make any comparison?
Yes, sir. So here we got the from the same system we have done this one. This will be installed in the future. For this, we got the efficiency of the 18% to 15%. And the implemented systems, what we have done, we covered the system side panels, and we got it from the 18% to 22%. So that is the difference of the existing system and the external proposed system. So we enhance with the efficiency, powers, and current outputs. That is the means it's simply to get the maximum output from the solar panels.
Even from different parameters for the solar and power. They are only it's not solar, but this prototype.
Yeah, but
What are the design parameters for this prototype? How you design the motor? How you select the motor?
so this prototype is a very small answer due to the economic benefit. This is a DC motor. It's 150 RPM, and this just motor will be moved from this side. And we done this one by using the Arduino prototype.
It is giving you only certain days it will go.
That will be done by the impact of the dust. I write the code based upon the one. If the dust is means crossed to the limited levels, then the slide will be moved from the one end to the other.
How do you measure the best by looking at the efficiency?
Intensity of the dust. Yeah, exactly, by efficiency. If the level of the efficiency will be increased because of the dust only. So if I just for example, I run the 15% as efficiency. If that is less than the 14.9 or the 14.5, then the model will be moved. Yeah, we get from the current and voltage system. Why we mostly all those benefits. So obviously the efficiency will be disturbed because of the building, wind, dust, and air. Yeah. It's obviously that when there is a mistake in the building, then it will be gives the sensor. Actually, I didn't. This is a small. As you see, means if there is a drop in voltage or current in efficiency, means with respect of the building angle or the dust particles or the wind direction with the panels will be disturbed. These constraints are problem and these are essential to them. If these parameters are disturbed within the limited levels what you have done, then you will get the alert. Means you will get the alert. By getting that one, but the mean we didn't get the alert, the water will get alert and it will be clean from this side.
But you need to hold this side and the other side.
So means to hold the covers and the so there is a sheet over the So that's why we wrote we have to cover the panel, and that wheel has to move itself.
If we cover the panel, then the road will be straight.
We have the brushes here, sir, and then you can see here. This will be rotated over, sir, from this angle to this angle. Means it's 0 and you take it as a this angle, and if you right to left and left to right. And simply we are directing the motor directions. That's it. And the cover is over there, and it will go from one end to other.
This is powered by the same solar panel.
So
The power of the motor comes from the solar panel.
yeah, yes, sir. Exactly. Yeah, we can use that one.
Then why you need an AC/DC converter?
Come again, sir.
You have an AC/DC converter.
Yes.
Why you need that?
Actually, for the we have the in Parifix, we have the other motors for irrigation systems.
This is getting power from outside.
No, sir. Actually, the power will be generated from the solar panels.
Okay.
So the power will be given to these motors. And this converter is used for the external motors, irrigation purpose motors.
Question from next.
Hello, am I audible to you? Hello?
Recording in progress.
Hello, am I audible to you?
Yes, yes.
Which system you are working on, indoor application or outdoor application?
Actually, we're done with the both the things. Experimental conductance is done on the indoor and outdoor. Right now, we are implementing on outdoor systems.
Outdoor system. Are you
Yeah.
considering the shade effect of shading?
Yes, ma'am.
Consider that also.
Yeah.
Okay. And have you done any simulation?
No, ma'am. Actually, this is a hardware system.
Now you can do the simulation also, no? So that you can
Okay.
analyze the effects of shading and other things.
Actually, the
And,
panel's output is measured, ma'am, by using of simulations only. But the entire system is not designed in the simulation.
Okay. And one more thing is that indoor experimental setup is mentioned. How
Yeah.
did you measure the solar radiance in that case?
Means actually comparing to the indoor and the outdoor, the efficiency will be varies, ma'am, in little bit. So to get the perfect efficiency, we just done that. It's an trial and error, ma'am, to do some extent.
Okay. Then it's fine. And only the comment about your presentation is you have pasted that abstract and the conclusion as it is. Don't do that. The better practice of presentation is you put only the points.
Okay,
Otherwise,
ma'am.
it is fine. Best wishes.
Sure.
Any questions from the public? Any questions? Okay, thank you.
myself and welcome my projects. Topic is Robert's aptitude control of launch vehicle using X-Infinity control. These are the contents of our project. Case has always been of keen interest to humans because it prone to contain all information about the plant. Here we are using a launch vehicle as a plant. A launch vehicle is a carrier rocket which is used to transfer a payload from Earth's surface to space. As we all know, it's a highly aerodynamically unstable system. So here we are designing a controller to stabilize our system. We are using a H-infinity controller to minimize the closed loop impact of perturbation as well as to stabilize our system. So as a first step of modeling, designing a controller, it's important to get the plant transfer function. So we are doing the modeling of launch vehicle. A launch vehicle has got both rigid body dynamics as well as the flexible body dynamics. Here in our presentation, we are only taking the rigid body dynamics. We assume that they do not deform under the action of any applied forces. The input to the launch vehicle is thrust angle, delta, and the output is attitudinal angle. From the force equation and moment equation, the lateral acceleration and angular acceleration can be obtained, which is given in equation 1 and 2. From the figure, we can see that angle of attack alpha is theta plus z dot by v plus alpha w. Then z dot by v and alpha w are the components of the thing. So those components can be negative. It is given in equation 4. Taking the Laplace transform and combining with equation 5, we get the transfer function of the system theta of x by delta plus equal to mu c by x square minus mu alpha, which is given in equation 7, where mu c is the control moment coefficient and mu alpha is the aerodynamic moment coefficient. The range of mu c and mu alpha is given in the table. Equation 8 shows the nominal transfer function of a nominal plant. Figure 2 and figure 3 represents the pole zero flow and step response of the system. From the figure, we can see that our system is unstable. So here we are designing a H-infinity controller. It is the most advanced technique and was proposed by Safety. Among different methods, we are using the H-infinity loop shaping technique for design. We are adding performance weight in the design stage to get our desired performance. Coming to the design of H-infinity controller, first we have obtained the plant transfer function. Next, we check the stability criteria as a performance criteria. Stability criteria states that the roots of the characteristic equation 1 plus u of s k of s equal to 0 should lie on the left upper s plane, and the performance criteria states that for all frequencies where the disturbance is high, our sensitivity function should be small. Then we have to find an appropriate weight for our controller. Then using the MATLAB commands, we create the augmented plan and also we synthesize our controller chaos. Figure 4 and figure 5 shows a plan model of our H-infinity controller. Then W is our reference signal and Y is our output signal. Here the problem is to regulate the output Y should look like the reference signal W. So that we are introducing a controller A. The input to the controller is E, is the error signal, the difference between our input to the output. Here we consider two transfer functions. One is our sensitivity function S and complementary sensitivity function P given in equation 9 and 10. Our sensitivity function is the ratio of output to the disturbance and complementary sensitivity function is the ratio of output to our input. So selection of the weight is the most important design in our project. Selection of weight for a robust controller is intended to reduce the H-infinity norm of the system. For that, we are introducing 3 weights to the system, that is WS, WKS and WT. Where WS is the performance weight, WT is the robustness weight, and WKS is the weight which is a constant. It is used to limit our control. WS limits our sensitivity function and WT limits are complementary sensitivity function. For selecting the weights, there are no hard and fast rules. We are doing this by reducing our sensitivity function and complementary sensitivity function. To obtain this, we just simply reduce the magnitude S and T such that it satisfies the equation level. Figure 6 and figure 7 represents the graph, shows a graphical representation of a equation level. The weight functions are nothing but are Laplace compensators, and equation 12 and 13 are the empirical formula used to determine the weights. So as I said earlier, there are no hard and fast rules for finding the weights. Either we can use the trial and error method, or what we have done is we have done with the automatic weight selection algorithm, which is used for our long-taken system. The input to the algorithm was our plant transfer function and initialize the values of A, M, and N as 1, 0.1, and 0.0. Then we found out our WX and WT. Then using the MATLAB command, we find the augmented plant P and the controller K. Next, after this, we have to check whether our cost function gamma is less than 1. If it is not less than 1, then we have to make necessary changes, adjust the values of A, M, and L, and repeat the before steps. If it is less than 1, then we have to check whether our equation level is satisfied, which is this. And if these conditions are satisfied, then we tune our WKS, and lastly we get the optimum controller KFS. To check whether we get the best performance gamma value, we have used the bisection algorithm. Here we initialize our lower limit gamma minus S0 and gamma plus S1, and we initialize a variable gamma as the average of gamma plus and gamma minus. Then we check whether a controller exists between a gamma minus and gamma. If a controller exists between that value, then we set gamma plus as gamma, or else we set the value of gamma minus as gamma. Then we repeat the step 3 and 4 until the difference between gamma plus and gamma minus is less than or equal to epsilon, where epsilon is a very small value. Then we return our controller K of S. So this table 2 shows the gamma values we obtained for using our bisection algorithm. Here, the first performance value is 0.601, which can be seen in the lowest value in the past test cases. Coming to the result part, equation 14 shows the transfer function of a controller, and equation 15 shows the weights that we obtained by doing the automatic weight selection algorithm. Figure 8 and figure 9 shows the Bode plot of S less than 1 by W and T less than 1 by W, which we can see that it satisfies our equation 11. And equation 10, figure 10 shows a singular value plot of the system. The red line depicts the maximum singular value. So in the figure, from the figure, we can say that all other singular values are below our maximum singular value. Coming to the results, our main objective was to get a response with overshoot less than 25% and a price time less than 1.5 seconds. So figure 11 shows the step response of a system in the controller which satisfy our desired criteria. Next, with the value of table 1, we have done the robustness check, and with all the 4 extreme limits also, we could say that our system with the controller was satisfied. Our result was satisfied. Next, we have the main advantage of the HMPD controller is disturbance detection problem. So we check whether it could handle disturbance. Figure 13 and figure 14 shows the output of the plant with step disturbance and the with pulse disturbance. So, first we started about the Rajagiri dynamics of launch vehicle, and we obtained the transfer function. From the Poisson plot, we could see the system was unstable. To stabilize the system, we introduced an infinity controller using automatic weight selection algorithm, and also we did robustness check and disturbance check. And from the simulation results, or our time domain specifications were met, and the disturbance rejection property of H50 controller was low.
So your entire research is based on the assumption that the plan is linear. We are talking about a launch vehicle and how far it is close to the reality.
We just, as a first step, we have taken only the result code. So we could start with the plan, the transfer function is a mono order transfer function. So we could check whether if this could work, then the higher order things could also be applicable with the same control.
Did you make any validation, hardware validation?
We tested for the simulation.
When you selected the bisectional code? There are other methods.
MATLAB comments there, simpler, comments to find the algorithm.
In the last slide, you have shown from 16, slide number 16. Some that step disturbance. What is the magnitude of this step?
We gave a 0.3 amplitude for the disturbance.
At time course.
Yes.
What was pulse also point?
Yes. So it's called focus study. How is the pressure? We check whether this condition in equation level, I specifically asked which by performance criteria we have chosen. That's what I was saying. Performance criteria are sure because what your estimation we see that because you are running point, right? Now you mentioned that you have lag need of policy. Lag WS, it's a weight function, it's actually a lag compensator, and WP is a lead compensator. Why do you think for a lag as a lead compensator? Lag compensator was used to stabilize the system, and the lead compensator was used to get a reduced rise time in the system. So what is that? Our objective was to reduce the rise time to less than 1.5 seconds. So then my question is back to the study. Because I was asking the second answer as this. You mentioned about we can take the project. So what is the M, A, and L? These are the variables in the equation 12 and 13. What was that? M was a high frequency disturbance lane, and A was a low frequency control system, and L was a constant. Okay, so what is the relevance of that high frequency disturbance and low frequency control system? Maybe the control system is really good, right? Yeah. So what is the relevance of snake parameters in your stabilized system, and also we have to look whether this controller could be whether this is a robust controller. No, I'm coming to the robustness. But what is the relevance of having n is equal to 1? N is equal to 1. N is equal to 0.1. And we have started with some minor values, right? So that's definitely has got some significance. And suppose if I put capital A is equal to 0.2, what will happen to your system? this conditions are there, condition equation is there. You have to check whether S is less than 1 by W and N is less than 1 by W. But that is frequency of it. One frequency of it. Now, coming to the most important part of the discussion, policies. What do you mean by policies? The Robertson says that not only for the nominal plant, but also for the neighboring values, the controller would be stable and it would attain our desired output. Nearby values means every the more specific. You might be putting a delta m plus delta n. Here we have given the info using plus 2 to 5 and 4 to 7. These values are taken from paper. So we just check whether in these range, if we put any of these values apart from one normal, then so you have considered with system parameters of your. You have not considered any disturbance or no. We only consider the coefficients where we neglect all the other results like wind and all the other results. Because by classifying your obviously supposed to put the uncertainty part, right? Uncertainty part of your system dynamics. And I will find that in your presentation. And if you do not have the uncertainty part, then how can you say about the losses? Just check with the range we have mentioned. With the range we have mentioned. It was not for just the normal plan. You have to, we just check whether this range which we actually gave could take the controller could take the values. Even if the values of unit change, whether the controller is able to. So what possibility have change the range of CM mu alpha from mu alpha to so what is the exact value of CM mu alpha? 4.54 and 3. So 4.54 plus 2 minus 2 and plus 2. That way. Or what is the no, these values they take from the paper, which most of the papers use these values as a nominal plan. So they also define the range. So the nominal plan we took of these values and we check whether you subtracted the 2 from 4.54 and how do you check the output? No, that's we just gave the extreme limits. Just we gave 2, 5, 4, and 7. We just gave the extreme limits to the you get that. Coming to figure 13. So that is some disturbance signal, right? Yes. This one are step response. First one is a step, and second one we have given the what do you mean step test? That is not step response. Initially your plan is setting around the plan right, and suddenly you are doing a stepping group. Is that correct?
Class എടുക്കാൻ
So even if a step of how much 1.3, no 1.3. Yeah, the input plus our disturbance is 0.3 as 1.3. So the disturbance step means how much 1.3. Yeah. So suppose same thing is going to be an impulse response of 0.3 magnitude. Right. What modification of how the picture will be. Each of step input. But you are giving an impulse input, same magnitude point. Yeah, you are giving an impulse disturbance. Right. In the second, but that is a disturbance.
Hello, am I audible? Hello, am I audible?
Normally, the step was supposed to be an underdone system, only coming back to one. But that is not.
Coming back to your point, right?
I mean, your research is good, but it needs sort of fine tuning. Make some prototype, maybe something which is hanging, you try to control that, the attitude of that, you should try to control. Then we'll make the project.
So that is compensated for improving your maximum as well as steady state performance. That is, your performance parameters are maximum as well as steady state. That has to be shown. Right. So all this point, okay, when you in your mind that you use it for your further research. But here, no.
When you are doing impact, there is sufficient material for your research. So it's a good project, but you have not done, I mean, there are some missing links.
Also, you can go beyond your parameters. So it's already mentioned that that will be the column. And you cannot say that since this is for the lower order, it will not be the higher order. It is not so. If it works in the lower order, it will not work in the higher order. That is a back statement. So what is needed? Decisions.
Hello,
Hello.
hello, am I audible to you? You are designing H infinity controller. What are the design specifications? By designing H infinity controller, what you want to obtain? Design specifications like a time domain specifications, anything you are planning to achieve?
Yeah, time domain specifications, we specially mentioned about the overshoot should be less than 25% and the rise time should be less than 1.5 seconds.
Of the uncompensated system after introducing the controller.
Yeah.
Okay, then how did you arrive at the weighting function?
At
In
the,
your design process, how did you arrive at the weighting functions? How did you choose the weighting functions?
we did the automatic weight selection algorithm.
Okay. And your controller is, I think, fourth order controller you are using. Finally, you are arriving at a fourth order controller. Any plan for model reduction, order reduction?
Yes.
Have you done that?
Actually,
Or,
no. We are getting a fourth order controller. It's actually a small drawback of H infinity controller too. Like initially the control order was 2 and we get a fourth order controller. So,
but you can do the order reduction. No, you can go for
yes,
the
we
order
can.
reduction.
Order, yes. Like
Yes, yes.
using a hybrid controllers, I think we can reduce the order.
And any plan for the implementation of the H infinity controller?
We are looking forward. We all are working, our team members are working. So if we get a chance, then.
Okay, think on those lines, how to implement the H infinity controller and how to reduce the order of the selected controller, etc. Best wishes.
Thank you.
3 months ago by the title Optimized Physical Consumption Models and Practices. The authors of the presentation are Jitin K. and M.R.
And optimize physical consumption model practices. For this and contents are system consider also operation system of solution basis inference conclusion introduction. We all are society for guarantee and secure power supply. And we all know that the fossil fuels which were used in high percentage is getting reduced these days. And we are depending on the renewable energy resources. And the most renewable energy resources which is available in a good to the north is solar and wind, and I am focusing on the solar case. And what is the advantage of renewable energy is that it is clean, cost effective, and easy, accessible, sustainable. And here the solar technology
And while considering this renewable energies, if a lot many people are using renewable energies, especially in solar case, I am considering about the prosumer. Prosumers are those persons who can produce and they utilize and they produce. Sorry, they produce, utilize, and they sell the energy to either to grid or some other persons who are in it. So what I'm doing is that I'm just combining this prosumers and it is known as a prosumer consortium model. And this will increase the productivity of the entire system, and the availability of the energy will be always in a good percentage. There will be no issue with the there will be no interruption with the process. That is the main advantage of this consumer consortium. The objective which I consider is that to minimize the utilization of fossil fuel-based power and maximize this financial benefits to the consumers, utilize the maximum amount of renewable energy and making the load demand forecasting is my objectives. Coming to the literature review, in case of microgrid, in microgrid, the most main person, like our main elements of microgrid is wind and solar. And in case of solar and wind, they produce energy and huge grids. They have a main role for the support of main grid source. So this will especially they will support in critical loads, which is needed to be in a guaranteed position. And with prosumers, as I mentioned, they produce and they distribute energy to the main persons. And this combination, this is my literature bit. And this is just a small model of prosumer consortium. They, you can see this figure. Here, 3 prosumer communities are there. They have a coordinator, and they have a community group is there. They have one more person trusted for the authorities. He will supply the power to the needed persons according to the availability. This is just model which I get from the paper. Now the system considered by myself is that I consider 20 prosumers, in which I made this 20 prosumers into 5 clusters, and this whole system is connected to the main grid, so that if there is any need of extra energy, I can present it. That is the main thing. These all prosumers, all these houses are powered by the solar rooftops. And the 2 models or 2 modes of operation I consider is that in mode 1, all the prosumers are connected in each other in case of every cluster, and these clusters are not getting connected, but they are connected to the grid. That is the one model which I consider means all these switches will be closed and these switches will be closed, but the switch in between each cluster will not be closed. That is one mode I consider. And the other mode, all the switches will be closed. They can transfer power to any person, any cluster, depending upon the need. So considering these 20 prosumers, the production power generation in 24 hours is this form. I can get the maximum power from 9 to say 3 p.m. 9 a.m. 3 p.m. I can get maximum power, and the power will be generated only from 6 a.m. to 6 p.m. or 7 p.m. maximum. After that, there is no power. As you know, there is no sun. And the power demand, the most is during the evening time, evening since 6 p.m. to say 9 p.m. or 10 p.m. The maximum power is needed. Still, in the daytime also will be of some amount of power. So the modes of operation, as I mentioned, I consider every this 20 clusters into 5 clusters, and they are connected to each other in one mode, and they are not connected to each other. First, these are the 2 modes of operation I consider. And the first mode, as the clusters are not connected to each other, I named it as prosumer model, and the second one, as all the communities are getting connected, I named it as prosumer consortium. Consortium in the sense is meaning itself is combining many. And the system model. Here, the system model, the main thing I consider is the demand. How much demand is needed of my place, and that demand should be able to cope up with the help of power generator and from the power grid. This is the only way I can get the power for demand. And those consumers who have surplus energy, they can they can transfer their power supply as per the need with some amount of cost, right? They will be keeping. And if they are in surplus, sorry, shortage, if the demand is more than the available energy for consumption from the solar, they can take from the grid also. This is the system I consider. And if a consumer supplies energy to another person, he will get or he will rate what price per unit according to the amount of energy. This is the simulation result I did in Python. So you can see in consumer model, in case of consumer model, as I mentioned, from 9 a.m. to say 5 p.m., there is power generation, and you can see this color selected generated power, and the demand is increased from 6 p.m. onwards. So in consumer model, these clusters are not getting connected to each other. So the surplus energy, some clusters is having some surplus energy. They are not giving to the other person, but some clusters will be in need of more energy. They will take the energy from the grid. So in consumer model, what happens is that they are mainly depending upon the grid energy instead of sharing it. But in the same case, when I consider the consumer conservation model, you can see here the previous case, here also the power is taken from the grid because they are not getting shared. In the second case, second mode, you can see the power taken from the grid is very low because they are sharing each other with the surplus energy which each person is having. So this is details I consider for one day. And the demand, you can see the demand for each person, one person. I consider one person for 24 hours. So you can see the demand. From 7 a.m., the demand is supplied by the solar power also. So less amount of energy is taken from the grid in consumer model, but in consumer consumption model, you can see that the generated power is utilized more. You take the 8 a.m. In the first case, 4,198 watts is utilized from the power generator, but in case of consumer consumption, the power generator utilized is 5,160. It means that the balanced amount is taken from the other consumers who have extra energy available. So while calculating this amount as per energy condition regulation condition, what I got is per day I can, for this systems I consider per day, I can save up to 264 rupees 75 per day if I utilize the consumer consumption model with comparing with the consumer model. So this is a case I've taken at 11 a.m. So because in 11 a.m. we have the maximum amount of we found that the maximum energy is produced during the noon time. So I just consider at 11 a.m. what happens. So in consumer model, the power generator is same, our demand is same, but the power utilized from the consumers is only 35,469. But when consider the consumer consumption model, the power utilized is 43,300. This is the difference of amount, the difference in the amount of energy utilized from the solar when the consumer consumption model is considered. And in the earlier case, the full 20 consumers, they are depending on 7,961 watts power from the grid. But in case of consumer consumption model, only 71 watts is utilized. This is the inference from that details I took. So during 8 a.m. to say 2 p.m., the consumer model is more depending on the grid. But in consumer consumption model, the dependence is very, very low. So the conclusion is that this personal construction model for optimized scheduling is done. And the financial benefit, as mentioned in the paper, the financial benefit is obtained. It reduces the dependency in the grid and it enhances the reliability with energy storage system also.
I'm concerned about the practical things, how it will be implemented, because here there are large number of switches between microgrids, between microgrid and the grid. And in engineering, you know that switching means you need switch gears and protection devices, which is normally installed in the substations. So all these things will now come to the consumer end. So the large number of switching and all, is it practical? Is it economical? And thirdly, who will monitor all these things?
Monitoring is, so for this case, it's not
Because now substation devices, so in the substation there are experienced engineers sitting there to monitor all these protection and switch gears. When all these switch gears and protection devices comes to the consumer end, I'm very confused about the implementation part.
implementation, as of my consideration, I'm not thinking about much into that area. But while considering this case, I think it can be made automated.
It's not, switching means it is not just open
Okay,
area
yeah.
housing. It is synchronization. 5 parameters has to be satisfied. It's not just switching. It is a synchronization issue. When there are large number of switches, each switching is a synchronization problem. That is the biggest problem in micro. Okay, mathematically, okay, you can share resources, you can share energy. That is okay. But this is practically, I mean, you should look into the practical aspects of implementing it in there is no, just look into that. My suggestion. Okay. Because now all the devices are in the substation. You are going out of all of them to the consumers. The normal consumers cannot handle it. They are expensive also. All the necessities for so every microgrid also there should be a substation. There should be a substation engineer. Then all these things are synchronization.
So practically, we can implement in this way, means operating all the switches at a time. Instead of that, when we have to operate, as sir said, individually we can do it next. Means let me take it as the area 1 and area 2. For example, I just giving that one, I just operated area 1. Then I just to see the monitor how the parameter switching will be. Means the same switching for the every area. Means every individual consumer. So instead of going all the consumers, first I have to see the C1 consumer one, and again to the C2, and infinity to Cn. So means instead of going to the directly to the implementation, we can go to the stepwise. Switching will be possible in this limited of areas, small areas, instead of taking as a large scale.
Actually, if it is a single consumer, switching is not a big problem. But when you are switching large amount of power, then that is a real switchgear and protection problem comes over there. That is my concern. I'm not saying it's not possible. We have to find the solution. Because we are slowly going towards microgrids and connecting microgrids. So we have to find the solution. But you have to conduct a feasibility analysis of and its practical aspect. That's only what my suggestion. I'm not saying it is not possible. It should be done somehow. Okay. This is my suggestion because you are doing impact of this. Yes. So you have enough time to analyze all this. See whether it is practically. Yes. Okay.
If the energy storage system is made reliable, we can support the entire system more. Here I'm not considering much with the battery side.
I have also seen any
Yeah.
actual.
Yeah, I haven't concerned much with the battery.
How can we assure about this?
No, I'm doing a study now. So I just like if the batteries can more energy can be supplied for the needed process because
I don't see to say about this contraction. One thing is right. What about the hormone coming the same way? About the hormone coming the same way. It also the financial downgradation.
just going to those studies now. I made a initial step.
So because the problem with renewable sources of energy, whether it is wind or solar, the main problem is first thing it is intermittent. It's not available all the time. Secondly, it is not dispatchable like our grid, not dispatchable. You cannot increase or decrease as you like. Second problem. Third problem what is only the injection of harmonics.
So that's not very hard that I can find arrangement of this.
Because of this harmony, the synchronization becomes difficult. When it connects, there will be a spark. The two systems will not be, identically.
Actually, I was focusing on the economic side. So I didn't want to this.
Your economic analysis is good. All those equations, mathematical equations.
But if you both then
Okay.
you should be able to implement it at the same time, it should be economically viable. So that way will already give us a position to your resource. Once you whole society, right? So that way.
Thank you. The suggestions if you have, nice to have.
So this is done economical.
Yeah.
In this side we have many things to do. The energy management system is a big issue to do in the renewable energy sources. In EVs also it is a big issue.
Hello. Am I audible? Yes, you are. You
Yes.
are trying to integrate renewable energy and get optimum unit cost,
Yes.
isn't it? Are you using any optimization method for that?
As of
You
now,
have just taken the readings and plotted. That's all only. Now, better I think you can use some optimization techniques for
I
getting
did,
unit
Then-
minimum unit cost.
I did with the GA.
A GA is used.
Genetic algorithm is used.
Okay. And also you can
And only I
refer.
got the values.
You can refer a lead certification guidelines. That is a leadership in energy and environment certification guidelines for the optimum design of renewable energy and how to integrate renewable energy into the building.
Can you mention that again?
Lead certification, LEED, lead
Okay,
certification,
okay.
LEED certification. In that clearly given the guidelines for the optimum design of renewable energy schemes.
Okay.
Have you used which simulation software is used?
Python. And the simulation I did with the Python code.
Okay. Good. The best wishes.
Thank you.
Better scope for doing research in this, I think.
Yeah, thank you.
Okay.
Thank you.
Our next presentation is by paper ID ICACC 123. The title is A Review on Battery Management System and its Application in Electric Vehicle. The authors of the presentation are Smarnika Mishra, Sharad Chandra, and Rajat Kumar. The presentation will be held online and the speaker is Smarnika Mishra.
Good afternoon to all. I am Swarnika Mishra, research scholar from KIT University. My topic is a review on battery management system and its application in electric vehicle. This is my outlines, introduction, battery management system, modeling of lithium-ion battery, estimation of battery status, conclusions and references. First go to the introduction. Actually, presently the electric vehicles are considered the most appropriate solution for the replacement of the internal combustion engine vehicle. So the development of electric vehicle technology is growing rapidly, and the battery technology is important concept for the development of the electric vehicle. So the EV performance mainly depends upon battery performance. So battery management, that's why because it is the because for the battery management system takes a role. So recently, the lithium-ion battery is mainly used as a battery in electric vehicle due to the small weight, high energy density, and capability of fast charging. So considering the dynamic performance, economy, and safety friendliness to the environment of the electric vehicles, the BMS designed to meet the challenges like the energy management of the battery, reduction of the heating time at low temperature, and enhancing the remaining useful life, because the life of a battery is very important. So it gives the accurate predictions. The battery is managed and controlled by the BMS. So it is mainly focused to maintain the reliability and the safety. The state estimation of the battery is essential for the vehicle control and management of energy. Here my paper gives the review on the strategies like the battery modeling and the state estimations and predictions. The state estimation means the state to estimate the state of charge, state of health, and state of power, and prediction of the remaining useful life. Next to the battery management system. A battery management system is a device or a technology which maintains and controls the batteries. The battery management system consists of various actuators, sensors, controllers, along with the algorithms and the lines of the signals. The primary responsibility is to assure the safety as well as the reliability of the battery and gives the required information of the state for the vehicle control, energy management. Furthermore, it is also expected to collect the real data, means the terminal voltage, current, and the temperature, and other parameters of the individual cells in a battery. And the strategies of the embedded algorithms are used to estimate the battery state of charge, state of power, and state of health and remaining useful life. The estimation results are given to the vehicle control unit, which serve as the foundation or the management of the energy and control for the power distribution of the electric vehicle. So the battery management topology is also important for the extensive battery management. So electric vehicles are designed according to the different dynamic performance like the climbing ability, acceleration capability, and maximum speed. The technical requirement of the EV design need to connect the cells in series or parallel. It is very important how to design the battery or arrange the battery cells. The battery control unit, the BCU, and the battery monitoring circuit are had circuit, and these are connected. These are connected accordingly. The BMS topology is classified into centralized and distributed according to the structure design among the BCU, means the battery controlling unit, and battery monitoring unit means the BMC and the cells. In the centralized, the BMS and BMC, in centralized BMS, the BMC and BCU are incorporated in a single PCB. And in distributed topology, the BCU and BMC are arranged separately. The temperature, cell voltage, current, and security and consistency are managed by the BMC. These are the functions. These are the functions of the BMS. First, the data connection, the data collections, because the working environment, of the battery in the electric vehicle is very complicated, and so EV needs to adapt the complex and changing environment. Means the battery needs to operate in a complex and variable humid environment all year around. And in addition, as road conditions and drivers change, the battery needs to be adapted to rapidly changing load in order to accurately obtain the working conditions. So the accurate data collection is required. Here the battery pack is there, so the batteries are connected parallel and series manner, and here the voltage, current, cell voltage, temperature, all are the real-time data which is given to the sampling circuit. Here the sampling circuit, we can use the MOSFET, and then then the takes data from and gives the data to the control unit. By using this control unit, we can estimate the SOC, SOS, and SOP and RUL. After that, this can be communicated with the display instrument or the vehicle controller, and the data collection is calibrated. Then next is the state monitoring. Here the state monitoring means monitoring the state of battery, means the state of charge, state of health, and state of power, and remaining useful life. Then the safety operation. The battery needs the safety, because it depends upon the charging. If we give more charge to the battery, then the battery it gives impact to the battery. So for the safety protection, BMS work for the safety protection of the battery, and the charging control is also very important. Then energy management. For the energy management means again the energy, means the voltage, current can be properly managed. That can be done by the BMS. Then the thermal management is also be one function for of the BMS. And then the information management. Information management means after getting all the data, means so many a lot of data are given to this battery. After then it's stored in this control circuit. After getting this large number of data, then we just select the less data by filtering this all the large number of data. Then it is go to this go to this vehicle controller, so that means information management means so we can control the battery better way. Then the modeling of the lithium-ion battery. Here we are using the lithium-ion battery. So because of the complexity of the electrochemical reactions inside the battery, the lithium-ion batteries are influenced by various factors and uncertain. There is a multidisciplinary problem to establish the mathematical model of the battery, which is an unsolved challenge in industry as well as the academia. So in the BMS, the current is input quantity, whereas the terminal voltage temperature is output quantity, and the battery terminal voltage is separated into two parts. One is the dynamic, another is the static. The dynamic part incorporates the first changing voltage component, which is the ohmic polarization, whereas the concentration and the electrochemical polarization are the slow changing voltage component. The open circuit voltage and the hysteresis voltage are the two primary components of the static part. Then the existing state and the past inducement approach of the battery is strongly linked by the hysteresis voltage component for designing the accurate and reliable battery state estimation algorithm and to develop the more accurate BMS in recent energy vehicles. Now, advanced battery modeling is required. The different battery models are it may be the electrochemical model, equivalent circuit model, and black box model. But nowadays we are using the equivalent circuit model, so it gives the better result. And here the different type of equivalent circuit models are there. One is the CM, another Thevenin. Here, this is the circuit, and this the R0 means here VOC and the R0 the open circuit voltage and the internal resistance respectively, and it gives the output voltage, and this the equations. This is another Thevenin is in this model. The internal resistance is include here. R0 is the internal resistance. Here one parallel circuit means the one capacitor and the resistors are connected here. Then